Hey everybody, I'm back! And if you're actually watching this video, it means that everything appears to be working on my computer, which has been a nightmare. But anyway, we're back and we're going to dive right into Linux Plus. Now, we're just about done with the 1.3 objective. And of course, we've broken this up. So this is section 1.3.4, according to my video titles. But anyway, we're looking at file system management using a bunch of different types of file systems. And also, I want to cover RAID implementations. Now, this is very limited in scope. It just says we're inspecting RAID implementations using the proc mdstat virtual file system. And so we're going to do that, but I'm also going to build a RAID array really quickly because it's important to understand the difference between a RAID array built with mdadm and a BTRFS type RAID system, because you can do RAID both ways. This is the traditional way, and this is possible. I've actually never done it in production, but we're going to do it right now today. Okay, so we're here on actually a brand new Mate install, but I did install Mate on our new virtual machine that we're using here. And if we look at LSBLK, notice I'm the root user. We're going to be messing with partitions and file systems. So I just did sudo space -l root so I could become root on the system without having to type sudo for every command. Anyway, LSBLK is going to show us all of our block devices. We've learned that before. I just want to explain the setup here really quickly. So we have SDA, and SDA1 is just a partition that takes up the entire drive that I've created. So that's one partition that we have. SDB is another drive that doesn't have any partitions on it at all. You'll notice both of those are 10 gigabytes in size. Actually, yeah, both of those are 10 gigabytes in size. And then SDC is a third hard drive. And what I've done is I've chopped this up into 4 different partitions, which is a weird way to implement RAID because generally you use multiple devices, but I didn't want to put a whole bunch of drives in here. So these are the partitions that we're going to use when we set up RAID. So that's why it's in 4 partitions. SDC 1, 2, 3, and 4. Now, one difference that you might notice from our last virtual machine as we were learning Linux Plus is that the root device on this is VDA. That's just because I'm using a different virtualization system, and this is a different type of virtual hard drive. When I added additional drives, I used SATA drives so that they would be more familiar to us, but VDA is just a different type of hard drive, specifically used with KVM and QEMU instead of VirtualBox, which is what I was using before. Anyway, that's just if you wondered what VDA was, that's why it's there. So the first thing I want to do is cover EXT file systems. EXT is probably the most commonly installed file system on Linux distributions, and EXT4 is the most recent and the one that's almost always used. You'll rarely see any EXT file system that's not EXT4 these days. So the first thing we're going to do is do mkfs and then dot. And I'm going to hit tab a couple times just to show you all of the options that we have for installing a file system on a particular partition. Okay, we have all of these different things are installed. We're going to do ext4, but we could do exfat if we wanted to like format a drive and then have Windows be able to see it. NTFS, XFS we're going to use later, BTRFS we're going to look at. These are all the options that are installed on my current system. So mkfs dot and then ext4 is what I want to install on the partition, and we're going to do that. Dev sda1. Okay, so it has formatted that partition using ext4. So we could mount that onto a partition or onto a directory on our system, and then we would have access to that drive. We've mounted things before, but when you are scanning and making changes to a file system, it's almost always ideal to not have it mounted. Okay, it's kind of important not to have it mounted, in fact, when you are doing things like checking. So we have a freshly formatted ext4 partition. One of the tools we're going to look at is dump e2fs. So if we were to say dump e2fs and then dev sda1, which is that partition we just did, would actually give us a ton of information, like scroll through all these different things showing the different block groups and stuff like that. What I generally would like to do, but let's just look at the very top of the line. So if we do that same command and then we pipe it through head N20, it'll just show us the top 20 lines of that output. So we can see it on screen here, and it'll show us basically, it does the file system volume doesn't have a name. It it says that the last mount time is unavailable because it's never been mounted. Okay, this is just all sorts of information that you can see about the partition itself. Okay, which again, it's a partition we could mount and use on our file system. Now, if there were something wrong or we're getting errors on our system, generally what we would do is run FISC. You've probably heard somebody say FISC or FS check, or however people say the word that isn't really a word. There's a little bit of a nuance here. The actual command, and this is one that you should know for the Linux Plus certification, is E2FSCK, and then you would tell it what partition you want it to scan. So in our case, dev SDA1, it'll scan it. It says it's clean. Okay, so that's awesome. But if we do this, just FSCK dev SDA1, the exact same thing happens. And that's because FSCK all on its own is kind of a front end to the various file system checks, whether you have an EXT file system or like an XFS file system. It will look and load the appropriate tools usually. We'll talk about that later with XFS, but you can use either one, FISC or E2 FISC, but for the certification exam, know that E2FSCK is for checking EXT file systems, EXT2, EXT3, EXT4. And if you run it, it will check it and fix it if there are minor errors. Again, you want to do that when it's not mounted on the file system. All right, let's clear the screen again. So that's how we would do a quick repair. If you want to actually just look at the information about it, we can type tune to FS -L for list out everything that it can tell us about it, and then what file system, so dev SDA1, and it will give us all of this information about the hard drive file system, that we put on there. And this is the same tool that we would change some of these things. Now, usually you're not going to change anything, with possibly one exception. So this is the current mount count, like how many times it's been mounted. Again, it's never been mounted. We just formatted it. And then the maximum mount count by default is -1. Now, what maximum mount count, which is a mouthful, means is how many times the file system can be mounted, which is usually on reboot. Like when it reboots the computer, it will mount it. How many times it can be mounted before it has to run FISC or E2FSCK on itself to make sure everything is going well. And by default, -1 means never check it. So if you want it to periodically check, and depending on how often your system is rebooted, you might want that to be a small number or a big number. You change that number, and then when the system reboots, it will check if we set it in FS tab. So let me show you how we would change that mount count, and I'll explain how that coincides with something we learned earlier in FS tab. So this is where the information is, but we can change it using the same tool. So tune to FS -C will allow us to change the maximum mount count, if you will. And if we change this to like 5 times, dev SDA1, and then we look at the listing again, now we'll see the maximum mount count is 5. And that means after it's mounted 5 times, the next time it's mounted, before it mounts, it will run E2FSCK. All right, now let's really quickly look at an FS tab file. So vi, etc. FS tab. And you may remember when we learned how to use FS tab, these last 2 fields. Now this first one is dump, which is not used very much anymore. But this pass field right here, this can be either 0, 1, or 2. If it's a 0, it means don't check it on boot. So even if we set that maximum mount count to like 5 and it's been mounted 10 times, if this is at a 0, it's still not going to scan it. We have to both have that maximal mount count set and exceeded, and then when it boots up and tries to mount it, if this is 1, you set it for 1 for the root partition, which means that it needs to mount it before it even starts running the system, right? Because the root partition is where everything is stored. So if it's a 1, it does that one first, and then 2. So if it's a 2 right here, and it's like the home partition or something that you're mounting, or like the opt partition, whatever other partition it might be, you would set that to 2. And as long as it's not 0 here, when the system boots up, if you've exceeded the maximal mount count that we just set with E2FSCK, or Tune2FS, then it will actually initiate a file system check before it mounts the file system. I know that was a lot of information, but it's really important to understand how those things all work together. You have to have all of those things set in order for it to do an automatic scan when it is mounted. All right, so let's clear the screen because there's one more EXT file system thing I'll need to show you, and that is resize 2FS. And you'll see the pattern here. It's 2FS for most things. Tune 2FS, E2FSCK, resize 2FS is how we resize a partition. And to do this, you can either grow it or shrink it. If it's full of data, you can't shrink it down too much, right? But as long as there's space, I mean, there's nothing on ours right now. So we could actually resize it. So let's do resize 2FS and then the partition that we want. So dev SDA1, and then how big we want to make it, right? Remember, this is is this a 10 gigabyte? Yeah, this is a 10 gigabyte partition. So let's make it 5 gigabytes. All right, so if we do that, resizing the file system, boom, 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 file system is now that big. Let's do a mkdir test just so we can mount it. Mount dev SDA1 on test. And now if we do df-h, we're going to see that our file system is 4.9 gigs, or it's 5 gigs, okay? So we have shrunk it down from that full 10 gigabyte partition to a 5 gigabyte file system. So let's unmount that. And now let's resize it back. If you do resize 2FS and you tell it the partition, and you don't give it any arguments, it will fill up the entire partition. So if we just press enter, it will it's going to tell us we have to check it first to make sure that it can be resized. So E2FSCK-F, which means fix it, force it to fix it, SDA1. Okay, so it's been checked. And now if we resize 2FS, dev SDA1, now it will resize it. Let's mount it again. And now let's do it df-h. And now you'll see down here, we have the full 10 gigabyte partition. I know there's a lot of stuff to do with EXT partitions, but I wanted to give you the full gamut of what you can do, and those are the types of tools that you'll be using when you manipulate them. All right, so let's unmount that just so we can use this partition again. Because the next set of tools we're going to go a little bit quicker on, they're the XFS tools. There are different tools to manipulate an XFS file system, and XFS isn't used as often as the EXT file systems. I think Red Hat still uses XFS, so I mean, it is good. It's a good file system, but you need to know it uses different tools when you like repair it and stuff like that, sort of. Let me show you what I mean. Let's quickly format our partition. So mkfs XFS dev SDA1. Oh, because there's already a file system, it says I have to force it. So I'm gonna dash F to force it to format it. Okay, so it formatted it. Now it's an XFS file system on there instead of ext4. Now remember I said FSCK is a front end, so we could do FSCK dev SDA1, and it doesn't exactly give us an error, but it doesn't really do anything either. It just tells us, okay, this is XFS. I really can't do much. If you want to do something, you need to use XFS repair. Dev SDA1, it goes through, it checks it, and if there's anything wrong, it would fix it. And that's pretty much just like E2FSCK for an EXT file system. XFS_repair is how you repair an XFS partition. Now there is XFS growFS dev SDA1, but there's two problems. One, it will only grow the file system if it's mounted, but it's already using the entire partition, and you can't shrink an XFS file system. You can only grow it, which is a little bit frustrating, but that's how you would do it. If you had a partition, especially if you were using like LVM and you expanded the logical volume, then you could use XFS growFS to expand the file system to fill that entire logical volume if you're using LVM. Okay, so that's generally why you would use XFS growFS, but you can't shrink one. It's important to know that. And then really quickly, there's a couple more things we can do. XFS info will, I'm going to tell it what device, SDA1, will give us information about it. If we look at the block ID, you'll see this partition down here. It doesn't have any label. I mean, it has, partition ID, UUID, but it doesn't have a label. And we could actually use XFS admin -L, my label, dev SDA1, and now it has added a label so we could mount it in XFS tab using a label instead of the UUID. And if we look right here, and you'll see now we have that label, my label. And that's pretty much all we're going to look at with XFS. The next thing I want to talk about is RAID partitions. And I'm going to go really fast here because remember, the objective only says that you need to inspect RAID stuff. So really quickly, we're going to create a RAID device, which will be MD0 using all of those partitions. So LSBLK. So we have SDC 1, 2, 3, and 4. So we're just going to use all 4 of them. So we're going to say mdadm, that's the MD administrator program. This is how we manage RAID devices, software RAID devices on Linux. And we would do create dev md0, and I'm going to do RAID level 5. So it's going to be RAID 5, RAID devices equals 4. We're going to have 4 different devices. Again, they'd normally be different hard drives, not partitions on the same hard drive. And then we list them out. Dev SD C1, C2, C3, and dev SD C4. Yes, it's because I was fiddling with it earlier. It noticed there's a partition table on there, but there's nothing. We're going to completely wipe this out. Defaulting to version 1. So the array has started. Okay, so we've created dev md0, which we can use as a regular device to format a partition on. But the first thing I want to show you is if we look at proc md stat, that's going to show us the current condition of our RAID devices on our system. And here, MD0, that's the device we just created. It shows these are all the devices on it. It has information about it. It says recovery at 10%. And that's because if we do it again, it's gone up more. It's because it has to build that initial RAID array, meaning it has to strike parity across all 4 of those devices. So it's building it. If we had really large drives, it would take longer, but it's going to build it. We could still use it, but that's actually, this is probably what you need to know for the exam. If you look at proc md stat, it's going to show the current status of all of your RAID devices on your system, and this is our RAID device. Now, Linux is really smart. When we reboot the computer, it will almost certainly find all of those RAID partitions and reassemble it into MD0, but we could stack the deck, so to speak, by making a configuration file. Again, it will almost always auto-detect it. However, we could do mdadm detail scan, and this will show us the information in a configuration file format. So if we take that and we redirect it into etc mdadm mdadm.conf and just rewrite that conf file with that information, now it will definitely find and rebuild that MD0 device every time the system boots up. Now, even though building an array wasn't part of the objective, I wanted to show you how traditional software RAID works, because ButterFS does do RAID, but it's drastically different than using software RAID or mdadm on a system. It's newer and it's just different conceptually, okay? So we're going to go and set up a ButterFS file systems and then make a quick ButterFS RAID. Let's just do ButterFS together. I'll show you what I'm talking about. Okay, I paused the video really quick and I just wiped out SDA and SDB. So LSBLK, we're going to see SDA and SDB have no partitions on them at all. And generally when you work with ButterFS, you will just create a ButterFS file system directly on a device. You don't normally use partitions. Okay, so we're going to do that now. We're going to say mkfs ButterFS dev SDA. Okay, so it's done that. It's created the ButterFS file system on there. We're going to do the exact same thing for dev SDB. Okay, so now we have 2 ButterFS file systems, one on dev SDA and one on dev SDB. So let's take dev SDA and mount it really quick. So mount dev SDA, and we'll mount it onto our test folder here. And if we do df-h, we're going to see that here is a 10 gigabyte size partition on root.test. Okay, sure enough, it's right there, dev SDA. Now, we also have dev SDB. And with ButterFS, we can actually add them together on one mount so that they work together. So if we do BTRFS device usage of the folder test, it's going to show us that it has one device, dev SDA, and the device size is this. It has this much unallocated. So basically it just shows us we have one drive and that's how big it is. But here's where things get funny. If we were to say BTRFS device add dev SDB, our second ButterFS device, and if we add that to test, we add it to our mount. Oh, and if we add it to an existing mount, it's going to reformat it, but that's fine. We can just do -F. So it added it to our mount, and now if we look, BTRFS device usage test, now it shows us that there are two devices on there, right? Device 1 and device 2. And if we look at df-h, well, now all of a sudden there are 20 gigabytes available on root test because it's just using both drives. It just added them together. And then when it comes to mounting it, we can use either dev SDA or dev SDB when we mount it. And it doesn't matter. Either one we mount will be the same actual ButterFS unit. It gets really, really crazy, but that's how we can add it together. And it gets even better. We can actually, right here, it's just added them together. But let's say we wanted to have protection instead of additional storage. We wanted to have it mirror the second drive. So we want to add a second drive in case one of them fails. We don't want to lose any data. Well, we could actually do that just by doing ButterFS. Let's do balance, which would balance out the data on two of them. If we added one, it would actually balance the data stored on each of them. But we're going to do more than that. We're going to say ButterFS balance start -m convert, which means metadata convert to RAID 1, and D convert. We're going to convert the data to RAID 1 on our test folder. And it reallocated it as a RAID 1 device. Now, if there was a lot of data on there, it would have taken a lot longer because it would have had to like move things around and make sure that it was all set. But that it didn't take long at all. And now if we do df-h, we are back to only having 10 gigabytes, even though they're both on there. Because if we type ButterFS device usage of test, we'll see both of them are still on there. However, now they're in RAID 1. And so if one of them fails, we don't lose the data. I know that was a lot of work on the command line, but it was the same thing over and over using different tools. So really, if you have a virtualization system, add a couple hard drives and play with them, because that's really the best way to learn. ButterFS is very powerful. It can do more than just what I showed you with the RAID and adding extra devices. It can do snapshots, and it's amazing. It can do subvolumes inside. ButterFS is very powerful, but it can be confusing because it's different than traditional Linux file systems. So you really have to think differently when you're using ButterFS. But anyway, I hope that this was helpful. Thank you to all of my Patreon supporters who should be scrolling by over here, I think. And thank you for watching. Thank you for being patient, especially over the last couple weeks when my computer was dead. But I think we're back to things going well. I had slides, I had a VM. It's looking good. So thank you again for sticking around. And if I've learned anything these past 2 weeks, it's how important it is to learn everything. Do what you love. In my case, I really do love working on Linux. And most importantly, be kind. Thank you so much, and I will see you at the next video. Oh, I should probably press stop. Okay, bye.